Morning, all of you. Welcome to Sri Jayendra Rank Zone. In the previous lecture, this is class 11 redox reactions lecture I'm doing now. In the previous lecture, we have completed about how to do balancing of redox. No, we have completed how to calculate oxidation number and how to calculate oxidation number and how to identify whether it is redox reaction or not. So, what is oxidation? What is reduction? All those things we have done in the previous lecture. And in that lecture, very important is how to calculate oxidation number for a given element or for a given compound. Sorry. So that we have done now. Now in this lecture, will do how to balance the redox reactions, balancing of redox reactions, which is very, very important. So please listen carefully. How to balance redox reaction. Let us see now. A redox reaction is balanced by oxidation number method by the following steps. So a redox reaction is balanced by oxidation number method by following these steps. What are those steps? Let us see now. Write the skeletal equation with correct molecular formula. We have to write the skeletal equation completely with the not the number of molecules with the correct molecular formula of the reactants as well as products involved in the reaction. Identify the element undergoing oxidation and reduction by assigning the oxidation numbers for all the elements in the reactants and products. So we have to identify which is undergoing oxidation and which element is undergoing reduction. Anyway, in redox reactions, we know that one element is undergoing oxidation and other element is undergoing reduction. So in those cases, identify the element undergoing oxidation and reduction by assigning the oxidation numbers for the all the elements in the reactants as well as in products. So we need to do all these things. Next. So first step, second step is clear. Third step right now. Calculate the increase or decrease in oxidation numbers per atom and for the entire molecular ion involved in the reaction. So for example, if I say here MnO4 minus, example, I'm writing here clearly. So MnO4 minus changes to MnO2, for example. Then we have to calculate the increase in decrease in oxidation numbers. Now in this case, manganese. What is the oxidation state of manganese? Let us see x minus 8 is equal to minus 1 by applying oxidation state rules. So implies x is equal to plus 7. The same way here, x minus 4 is equal to 0 because it is neutral compound. It is equal to minus 1 because charge, it is neutral compound. So x is equal to 2. So plus 2. So plus 7 changes to plus 2. So we have to say this is called decrease in oxidation number. Decrease in oxidation number. In the same way, here Br minus changes to Br2, for example. So it is Br minus 1 and here it is 0. So it is called minus 1 changes to 0. It is increase in oxidation number. So like this, we have to identify decrease in oxidation number as well as increase in oxidation number for the entire molecular or ion involved in the reaction. If the extent of increase and decrease are not the same, then multiply by suitable numbers to make. Now here it is 5. Difference is what? 7 changes to 2. It is nothing but 5. 5 electrons. And here it is nothing but minus 1 changes to, so here we have to take 2 Br minus, so Br2. So minus 1 changes to 0, it means nothing but electron change, number of electron change is 2 electrons. So 5 and 2. So if the extent of increase and decrease are not same, here 5 and 2 are not same, then multiply the suitable numbers to make the increase. You have to multiply with this into 2 and you have to multiply with this into 5 for equating electrons. So to make the increase in oxidation number, to make the increase in oxidation number equal to the decrease in oxidation number. So like this we have to do. So I hope it is clear. Anyway, while solving the numericals, you can understand better. So just listen what is given in the slides. Just please listen and note down in your notes. Calculate the increase or decrease in oxidation numbers per atom and for the entire molecule or ion involved in the reaction. If the extent of increase and decrease are not the same, then multiply by suitable numbers to make the increase in oxidation number equal to the decrease in oxidation number. Let us see now what happens. Balance the charges on both sides by adding H plus or OH minus ions on either sides. So we have to balance the charges on both sides by adding H plus. Very important point here is if for acidic medium you have to add H plus, and for basic medium you have to add OH minus ions on either side. If the reaction is carried out in acidic medium, then add H plus ions, and if the reaction is carried out in basic medium, then add OH minus ions. Balance the number of hydrogen and oxygen atoms by adding water molecules on either side of the reaction. So to for the deficit of oxygen atoms, I'm writing here again, for the deficit of oxygen atoms, add equal number of water molecules. Add water molecules equal water molecules. So you have to add water molecules on either side of the reaction. Which side it is deficit, that side only we have to add. Which side it is less deficit means less. Which side it is less, that side only we have to add water molecules on either side of the reaction based on either left hand side or right hand side depending on the number of oxygen atoms. Whichever side is lesser the number of oxygen atoms, that side we have to add equal number of water molecules. Equal number of water molecules. For example, if two oxygen atoms are less, then we have to add two water molecules. So I hope it is clear. So in this way you have to do. Next. Now let us see examples. These are the rules for balancing redox reaction, acidic medium as well as basic medium. If acidic medium is there, add H plus ions, basic medium is OH minus ions. Let us see now. Balance the following redox reaction by oxidation number method. So here, this is very big method. So you need to take one more slide. So I'm writing the exact question again. I'm doing the solution. Then we'll check the answer. Let us see the solution now. Right. Now I'm writing the equation. So the given equation is MnO4 minus MnO4 minus plus Br minus gives rise to Br2 plus MnO2. This is the actual equation they are given. So first we need to write the change in oxidation numbers. So let us see MnO4 minus the oxidation state of manganese in this is MnO4 minus, again I'm writing neatly. So MnO4 minus. Let us take the oxidation state of manganese here. So X, let us take Mn is X. We know oxidation state of oxygen is -2 in most of the cases. So -2 into 4 is equal to -1. Why it is -1? Because the sum of all the oxygen states of a polyatomic ion is equal to the charge on the ion, is equal to charge on the ion. So basing on that rule, so X minus 8 is equal to -1 implies X is equal to +7. X is equal to how much? +7. So I'm keeping here, it is +7. Similarly, Br -1. So it is -1 already given. So here the oxygen state of individual molecule is 0. And here MnO2. So same, X minus 4 is equal to 0 because oxygen is -2. So X minus 4 is equal to 0 implies X is equal to +2. So we can write +2 here. Now you can see here manganese oxide changes to manganese dioxide, that is manganate ion. MnO4 minus changes to manganese dioxide. So it is changing from +7 to +2 if you see it clearly. So manganese MnO4 minus from +7 changes to MnO2, that is +4. This is called reduction half reaction. What is this called? Reduction half reaction. Why? Because manganese is changing from +7 to +4. Means it is decreasing oxidation number. It is nothing but what? MnO4 minus change to MnO2 is reduction. What is this called? It as reduction. Next, in the same way, let us take, I'll take it clearly. Let us take now Br minus changes to Br2. So this is called oxidation. What is this called? Because -1 changes to -1 changes to 0. So it is called what? Oxidation. because increase in oxidation number takes place. So it is called oxidation. Now, writing now here. Since this is reduction means what? Gaining of electrons. So how many electrons you should gain? MnO4 minus plus 7 minus 4, it is equal to 3 electrons. You should gain 3 electrons so that it can become MnO2. Similarly, Br minus should gain, and here you should take 2 Br minus because Br2 is there, Br minus is there. So 2 Br minus. So we can write 2 Br minus. The second step gives us to Br2. Since oxidation is gaining a losing of electrons, so losing of electrons, that side we have to write plus. So how many electrons it is losing? 2 electrons. Now, now next balancing oxygen atoms. Manganese is balanced, bromine is balanced. Now balancing oxygen atoms. So here oxygens, how many are there? 4, and here it is 2. So to the side deficit of oxygen atoms, add equal number of water molecules. To the side, here I'm writing simple words. To the side, deficit of oxygen atoms. Deficit of oxygen atoms. Add equal number of water molecules. And since it is acidic medium, and other side add equal number of H plus ions, because since this question is acidic medium, we have to add H plus ions. So stating that now, MnO4 minus, here manganese oxygen atoms are 3. So here 4 it is there, and here it is 2. Use H2 plus 3 electrons, just writing it clearly. So plus 3 electrons as it is, gives rise to MnO2 plus 4, and here it is plus how many oxygen atoms here on the right hand side? 2. Here it is 4. So we have to add equal number. So deficit is 2. So 2 water molecules. Since we have added 2 water molecules, we have to add 4 OH minus here plus 4 OH minus. This step is very important. And in case of bromine, nothing is there. So no oxygen. So anyway, it is balanced. Now, balancing electrons. What is the next step you have to do? Balancing electrons. Now here this side it is 3 electrons, this side is 2 electrons. So multiply this with 3, since there is no common factor, and here this whole equation with 2. Now after writing that, we have to write the equation 2MnO4 minus plus 6 electrons, because plus 8 OH minus gives rise to, so I'm writing directly the equation plus 2Br minus, 6Br minus gives rise to, so here this equation, products and reactants I'm writing. The products is the reactants of this side, and this reaction, both I'm writing here, gives rise to, now writing products 2MnO2 plus 8 water molecules. So 4 water molecules plus this side 3Br2 plus 6 electrons. Now both sides 6 electrons, 6 electrons. So 6 electrons and 6 electrons gets cancelled. Now this is the balanced equation. So the final balanced equation is 2MnO4 minus plus 8 OH minus plus 6 Br minus gives us to 2MnO2 plus 4 H2O plus 3 Br2. So this is the final equation. I hope it is clear. Again, I'm explaining this. So MnO4 minus plus Br minus gives us to Br2 plus MnO2. This is the skeletal equation, and they have given this is in acidic medium. So acidic medium, the numerical is given in the case of acidic medium. So I'm doing the same thing here. First step is writing the oxygen states of all the elements in the given reaction, either reactants as well as products. Write all the oxidation numbers of the reactants and products. Next, identify the elements which is undergoing oxidation state. Now here manganese from +7 changes to +2, so it is changing. As +7 changes to +2, it is decrease in oxidation number. It is called reduction. And similarly, +4 actually. Sorry, this is +4. So manganese +7 changes to +4. So this is called reduction. Similarly, Br minus changes to Br2, that is -1 change to 0. So this is called oxidation. Now, next what you have to write. So since reduction means nothing but gaining of electrons. So how many electrons it has to gain means just take the difference between the oxygen state of reactant as well as product. Take the difference between the oxygen state of reactant as well as product within the same element. So +7 changes to +4. So difference is 3. So we are adding 3 electrons because reduction is addition of electrons and oxidation is losing of electrons, gaining of electrons and losing of electrons. Here 2 Br minus because Br2 is given, so we have to multiply with 2. So 2 Br minus gives us to Br2. Since one bromine is 1 electron, so it should gain 1 electron to become 0. So it is nothing but 2 electrons. As it is losing 2 electrons, so you have to write on the right hand side. Now after that, very important step is this. What is this step now? To the side deficit of oxygen atoms, add equal number of water molecules, and the other side add equal number of H plus ions. Suppose since it is acidic medium, you have to add H plus ions. Suppose if it is basic medium, to the side deficit of oxygen atoms, add equal number of water molecules, and the other side add equal number of OH minus ions. So similarly for basic medium. Now as this question is acidic medium, so simply this statement is very important. To the side deficit of oxygen atoms, add equal number of water molecules, and the other side add equal number of H plus ions. Now here oxygens are 4 and here it is 2. So I'm adding MnO4 minus plus 3 electrons plus 2 water molecules. We are adding because this side it is only 2, so we have to add 2 water molecules. As we are adding 2 water molecules, we have to add equal number of OH minus ion. We have to add 4 H plus ions. Sorry. Yes, here it is 4 H plus. Very, very important. I have done mistake. Please note down since I thought it is basic medium. So since 2H2O, we have to add 8 H plus ions. How much is plus ions? 8 H plus ions. Because this is an acidic medium. So 4 H plus and this becomes 8 H plus. So to the other side we have to add equal number of H plus ions. Now like this. Now balancing the electrons. How to balance electrons? Since here 3 electrons and here it is 2 electrons. So by crisscross method, this should be multiplied with 2, this should be multiplied with 3. Now 2MnO4 minus plus 6 electrons plus 8H plus 6 Br minus gives H2. 2MnO2 plus 4H2 plus that 3Br2 plus 6 electrons, equating the equation both. After balancing electrons, we have to equate both the reactants as reactants and products as products. Now 6 electrons gets cancelled. So final equation is 2MnO4 minus plus 8H plus 6Br minus gives rise to 2MnO2 plus 4H2 plus 3Br2. So this is the answer. I hope you understood this. One more problem we can do so that it will be easy for us. So next. So I hope it is clear. Now I'm moving back to previous slide. Yes, I'll clear the diagrams. So 2MnO4 minus plus 6Br minus plus 8H plus gives us to 3Br2 plus 2MnO2 plus 4H2O. I hope it is clear. Let us do one more numerical. Example 2. Balance the following redox reaction by oxidation number method using acidic medium as well as basic medium. So oxidation number method, simple it is. So here +2 changes to +4. Increase in oxidation number is 2. So increase in oxidation number. Next, Cr plus 6. Actually, here it should be plus 6, changes to plus 3. So decrease in oxidation number. Decrease in oxidation number. Because plus 6 changes to plus 3. Because after calculating, this is 2x minus 14 is equal to minus 2. So how we got this, I will show you. 2x minus 14 is equal to minus 2. Because 2 chromiums are there. So 2x is equal to 12. So x is equal to 6. So like this we have to do. Now let us see how to balance this. Again, we'll do the same method by reduction, oxidation number method or reduction method. So let us think now. This is the answer. Now I'll write the scaled equation again. So Sn plus 2 plus Cr2O7 2 minus plus Sn plus 4 plus Cr plus 3. So here 2 and here it is 3 electron change. So we have to multiply with 3, and since 2 electron change, we have to multiply with 2. So 2 Cr plus 3, simple. So you'll get the answer. Anyway, I'll just tell you in clear method. Writing the question. Sn plus 2 plus Cr2O7 2 minus Sn plus 2 plus Cr2O7 2 minus gives rise to, sorry, this is Sn plus 4, I believe. Okay, let us see now. Moving to black previous slide. Yes, Sn plus 2 plus Cr2O7 2 minus Sn plus 4 plus Cr plus is equal to Sn plus 4 Sn plus 4 plus Cr plus 3. Now let us see. So here it is given plus 2, changes to plus 4, and Cr here chromium is 2x minus 14 is equal to minus 2. Same rule. That is sum of oxygen states upon polyatomic ion is equal to charge on the ion. So it is equal to minus 2. So 2x is equal to 12. So x is equal to 6 plus 6. So here it is plus 6 changing to plus 3, and 2 chromiums are there. So I'm writing here again 2 chromiums. So the difference in oxygen state is, here it is 2. In the case of this is 2, and in the here in the case of this is 3. So simple now. I'll just repeat again the same way we'll do the previous method. Now let us take this. Now we'll write here, since Sn plus 2 changes to Sn plus 4. This is called oxidation. This is called what? Oxidation, because it is increase in oxidation number. Because plus 2 changes to plus 4. Difference is 2 electrons. So, and here Cr2O7 2 minus changes to Cr plus 3. This is nothing but what? Decrease in oxidation number, because it is plus 6 changes to plus 3. So this is decrease in oxidation number. It is called as reduction. Now let us write Sn plus 2 gives rise to Sn plus 4 plus how many electron change? 2 electrons. So it should gain 2 electrons. So losing of electrons is called oxidation. So on the other side I'm writing, and here it is should gain 3 electrons. So but actually it should be total 6 electrons, because here it is what? Because we have to multiply with 2 chromiums. So each chromium is 3. So 2 chromiums, total 6. So Cr2O7 2 minus plus 6. And here also it should gain 6 electrons, gives rise to 2 Cr plus 3. Now it is clear. So 6 electrons and 2 electrons. So this should we have to multiply with 1, and common factor is 3. So for this we have to multiply with 3. I hope it is clear. So this is the electron, balancing electron. Now balancing oxygen atoms. Um, let us write the equation. Now here 7 oxygens and here no oxygen. So we have to multiply with the other side 7 water molecules, and this side 14H plus. Just wait. This multiplication of electrons we'll do later on. Balancing electrons after balancing oxygen atoms we'll do. So now let us see now. So here 7 oxygens and here 0. So we have to write Cr272 minus plus 6 electrons gives rise to 2 Cr plus 3 plus, very very important, 7 oxygens are there. So 7 water molecules. How many water molecules? 7 water. And the other side we have to add 14 H plus because 7 to say. Again, this is acidic medium since they have given acidic medium. Acidic medium. So I'm writing here again. So 14 H plus. Now, and here there is no question of oxygen, so no need to write anything. So writing the final equation now. And final equation, I have to balance the electrons. So balancing electrons, how to balance? Balancing electrons now. Balancing electrons. So here it is 2 electron and here it is 6 electron. So common factor, you have to multiply this with 3 and this with 1 because this is greater. So simply 3SN plus 2 plus, I'm adding the reactant side, plus Cr2O72 minus, straight away I'm adding, plus 6 electrons plus 14H plus gives rise to 3SN plus 4 plus 6 electrons because 2 3s are 6 plus 2 Cr plus 3 reactants and products side plus 7H2O. Now this is the entire equation. So 6 electrons and 6 electrons gets cancelled. So here we got 3SN plus 2 Cr2SN2 minus plus 14H plus gives us 3SN plus 4 plus 2 Cr plus 3 plus 7H2O. I hope it is clear. So this is the final equation. This is called balancing redox reaction by oxidation number method. Let us move it back. Yes. So it is 3SN plus 2 Cr2O72 minus plus 14H plus gives us 3SN plus 4 2 Cr plus 3 plus 7H2O. So this side equal, since 7 oxygens are there, this side no oxygen, so that's why you automatically with equal number of water molecules. And to other side, since it is acidic medium, we are adding equal number of H plus ions. So 7 2s are 14, so 14 H plus ions. I hope it is clear. It's very simple. So this type of questions you'll get. Next. Example 3, basic medium. Now let us do one problem in basic medium also so that you can understand it better. So let us take basic medium question right now. So I'm doing one more example for basic medium. So let us take basic medium. So the question is MnO4 minus plus NO2 minus. You can see in the previous question gives rise to MnO2. Since I am doing it here in the separate page, please note down whatever steps I have given and copy down this entire numerical in your classwork so that afterwards you can compare the answer easily. So now this is the equation NO3 minus. Now let us take first what is the first step? Writing oxygen states of the elements. So writing oxygen states of the elements here, manganese it is plus 7 since already we know because 2 minus x minus 8 is equal to minus 1. And nitrogen here, let us calculate nitrogen. X minus 4 is equal to minus 1 because it is polyatomic ion. The sum of the oxygen states of polyatomic ion is equal to charge. So nitrogen is plus 3. How much it is? Plus 3 because x is equal to plus 3. And here manganese dioxide, x minus 4 is equal to 0 plus x is equal to plus 4. So I'm writing here x is equal to plus 4. And nitrogen here, x minus 6 is equal to minus 1 and x is equal to plus 5. So I'm writing here plus 5. So first step is over, that is writing the oxygen states of all the elements in the skeletal equation. Next is second step is what? Identify the elements which are undergoing decrease in oxidation number and increase in oxidation number. So here we can say manganese dioxide, that is a manganate ion MnO4 minus plus 7 changes to plus 4 MnO2 And second one is what? The element nitrogen, NO2 minus, from plus 3 state changes to NO3 minus. Same like acidic medium only, but only the thing we have to add OH minus, that's all. So plus 5. Now here you can see here, plus 7 changes to plus 4, the difference is 3, and plus 3 changes to plus 5, difference is 2. Now writing here what happens. Next, to the side deficit of oxygen atom, add equal number of water molecules. So here, just simply I'm writing here, oxidation, this is called reduction, because decreasing oxidation number, and this is called oxidation because increasing oxidation number. Oxidation. Second step, just writing the number of electrons gained or lost. So MnO4 minus plus 7 changes to plus 4 means difference is 3. So it should gain 3 electrons because 7 minus 4 is equal to 3. Gives rise to MnO2 plus 4. Yes, I'm keeping here a column. Similarly, NO2 minus, because this is losing of electrons, gives rise to NO3 minus, plus difference is how much? 5 minus 3, it is 2 electrons. So I'm writing here 2 electrons. I hope it is clear. Now adding water molecules. MnO4. Here 4 oxygens and here 2. So we have to add 2 water molecules here. So MnO4 minus plus 3 electrons gives rise to MnO2 plus 2 water molecules. How many water molecules? 2 water molecules. And here other side equal number of OH minus ions. So 4, since 4 hydrogens, so 4 OH minus. Just I'm writing it clearly again. Similarly, NO2 minus, NO3 minus. So here it is, we have to one oxygen is deficit this side. So plus water molecule gives rise to NO3 minus plus 2 electrons plus 2 OH minus. Now I hope it is clear. Next, now electrons this side is 3, it is 2. So multiplying this equation with 3 and multiplying this equation with, sorry, this equation with 2 and this equation with 3. Just, so final writing here, 3 MnO4 minus, sorry, this is 2, no? 2 MnO4 minus plus 6 electrons. Why we are multiplying with 2 and 3? To balance electrons. Plus 6 electrons plus 8 OH minus. Reactant side I'm writing. Plus 3 NO2 minus plus 3 H2O gives rise to 2 MnO2. Writing reactants and parts 2 MnO2 plus 2 water molecules. Sorry, 2 to the 4. Writing here because we have to multiply with 2. 4 water molecules plus here 2 to the 4, 4 water molecules plus 3 NO3 minus plus 3 to the 6 electrons plus 6 OH minus. So 6 and 6 electrons gets cancelled. 8 OH minus, 6 OH minus, you have to bring OH minus to this side, so it becomes 2 OH minus on the other side. So this OH minus you have to bring this side, and water you have to bring that side. So final equation 2 MnO4 minus plus 8 OH is bigger than 6 OH, so we are bring the 6 OH this side, so it becomes 2 OH because 8 OH minus 6 OH is 2 OH plus 3 NO2 minus and 3H2, and this side it is 4H2, so bring this water molecules to that side, so it becomes 2 MnO2 plus 4 minus 3 1 H2O plus 3 NO3 minus. So this is the final equation. I hope it is clear. So the nothing but balancing redox reaction by oxidation method as well as oxidation half ion electron method. All the three are same here because anyway we have to do it like this only. I hope it is clear. Very, very important model. So in the examination, they'll ask number of electrons also, because for competitive exam, they will not have time to do this total numerical. So for competitive exam, they'll ask number of electrons involved, number of electrons involved, or final balance equation. So anyway, you have to do it. I hope it is clear. Next. So I'm clearing all the diagrams. Please copy down this numerical like this, so that you can do next numerical easily. So I'm showing the answer now, what we have got. So next example it is going. Yes. So 2MnO4 minus 3NO2 minus plus H2 on the left hand side and OH minus on the right hand side, since we got the same thing. So 2MnO2 plus 3NO3 plus 2OH minus. I hope it is clear. So this is the question now. Next question. Let us see. Example 4. Balance the following redox reaction by oxidation number method. This is again basic medium they are given. Follow the same footsteps. You'll definitely get the answer. So CrO2 minus plus ClO minus gives us to Cl minus plus CrO4 2 minus. So here itself I'll show it something like this. First step, identify the elements. So first step, writing all the oxygen states. So let us say X minus 4 is equal to minus 1, because it's a polyatomic ion. Similarly, X minus 2 is equal to minus 1 for chlorine. So X minus 4 is equal to minus 1 for chromium, and for chlorine it is X minus 2 is equal to minus 1. So X is equal to plus 3 here, because it becomes 4 minus 1. And here X is equal to minus 2 will go that side, X is equal to 1 plus 1. So plus 1, and here it is plus 3. And right hand side it is minus 1, given already. And left hand side it is CrO4 2 minus. So it is X minus 8 is equal to minus 2. So implies X is equal to minus 8 plus 2, it is equal to plus 6. So definitely we can see clearly electrons now itself, I'll say. So it is plus 3 change to plus 6. So it difference is 1 chromium, 1 chromium. So it is 3 electrons change. And this is minus 1, 0, plus 1. So minus plus 1 to minus 1, it is decreased by 2 units. Because plus 1 to minus 1, it is nothing but 2 electron. So we have to multiply with this with 2, and this with 3. Definitely. So you'll get 2 CrO2 minus 3 Cl minus 3 ClO minus. And oxygens, how many oxygens here? 2, and here it is 4. So 2H2O, 2OH minus. So I hope it is clear. Let us see the answer now. As I told you, 2. Why? Because this is 3 electron change. For chromium, plus 3 change to plus 3, 6. So difference is 3. So this is 3 and this is 2 electrons. So 2 will be multiplied with chromium and 6 will be multiplied with chlorine, because by crisscross method. So 2 electron change, that's why 2 CrO2. 2 CrO2, and this becomes 3 ClO minus, and this becomes 2 oxygens, 4 oxygens. So one deficit of oxygen is 2. So 2 OH minus. So 1 H2O, and you'll get the answer. I hope it is clear. So this is the answer. Same steps which you have followed in the previous question, like this you have to do. Next question. Please check, please do all these questions clearly, so that it will be easy for you to understand and to get more questions in the exam. Next question. Example 5. Balance the following redox reaction by oxidation number method. Just acidic medium again they have given. Simply I'll give you directly simple idea. This is plus 7, since already we have done this. This becomes plus 2. So difference is 5 electron, because 7 minus 2, 5. And this is C2O4 2 minus carbon. So let us take 2x minus 8 is equal to minus 2, plus 2x is equal to 8. Minus 2, that is equal to plus 6. So x is equal to plus 3. So plus 3 change to plus 4, because oxygen carbon. So this is 1 electron change, and 2. So this is 2 electron change, because 2 carbons are there. So here we'll write 2 carbons. So it is 2 electron change. Since this is 2 electron, this is 5 electron. So we have to multiply with carbon with 5 and manganese with 2. So this becomes 2MnO4 minus and 2Mn plus 2 on the right hand side. Similarly, just I'm giving basic idea directly doing, because in the competitive exams we have to do directly. So C2O4 minus and 2CO2. So we have to multiply with what? We have to multiply with what? We have to multiply with 5. So this becomes 5 C2O4 2 minus gives rise to 10 CO2. 5 to C2O for 2 minus gives us 10 CO2. Now let us see oxygen atoms. 4 oxygen atoms and here no oxygen atoms, so 4 H2O. And here we have to multiply with 4 H2O. And here 4 and here 2, we have to multiply with 2 H2O this side. So this side. So 4 plus 2, 6. So water molecules, you can do it easily. So anyway, you'll get 2MnO4 minus, sorry, 2MnO4 minus gives us 2Mn plus 2 and 5C2O4 minus 2 minus gives us 10 CO2. So afterwards, anyway, you'll get the answer. I'll show you water molecules also. Here, how many? 4 oxygen atoms in the left hand side for MnO4 minus. So you have to multiply with here how many water molecules you have to add. So we have to add 2 water molecules because, sorry, 4 water molecules. And the other side, 4 OH minus, sorry, 8 OH minus. Simply, I'm giving you example idea. And here it is 4, it is 2. So we have to add 2 water molecules this side. Since we're adding 2 water molecules, we have to add 4 OH minus here. So 8 OH minus plus 12. So this side 4H2O and 2H2O. So automatically this 4H2O minus and 4OH minus will change into this side. 8 minus 4 and 2 minus 1 1. So 4OH minus and 2H2O. So automatically you'll get the answer for oxygen also. Please see here. Yes, 2MnO4 minus 5C2O4 2 minus, as I told you, 16H plus, because we have to multiply with 2, no? So this becomes, sorry, here we have to multiply with 2. So we have to write the electrons also 16H plus, and this becomes acidic medium, no? Since we have done acidic medium, actually this should be acidic medium. I thought it is basic medium. So mistake. So 16H plus on the whole, because here how many water molecules we had? 4H2, so it should be 8H plus, and here it is 2, so 8, and here 4H plus, but this we have to multiply with 2, so 16H plus 10 CO2 plus 8H2O. Easily you'll get by this and this. I hope this you understood, and clearly this is 2Mn plus 2, 2MnO4, 5C2O4, 10 CO2. Balancing electrons also you can do easily. I hope it is clear. Next question. So like this we have done 5 examples, and next we'll do what is there in this chapter. Next topic in this chapter, balancing redox reaction by ion electron method. The same thing which you have done already. Again, I'll give you the clear instructions. Please go through it. Oxidation number method and ion electron method. To some extent, it is easy. Oxidation number method, easily we can do it by just giving in a rough manner. But here we have to do everything clearly. A redox reaction is balanced by ion electron method by following steps. The given equation should be written off in the ionic form, only ionic form. Very, very important. They will not give normal form, they'll give ionic form only. Separate the equation to half reactions, oxidation half reaction and reduction half reaction. Balance all other atoms except oxygen and hydrogen. First, we should balance the other atoms except oxygen and hydrogen, and balance the two half reactions separately by using the same method which you have done in oxidation number method. Balance the two reactions the same separately. Next, balance oxygen and hydrogen atoms by using water and H plus ions and OH minus ions. If it is acidic medium, add H plus. If it is basic medium, add OH minus. So as I told you, in acidic medium, we can use H plus ions and water molecules. And in basic medium, we can use OH minus ions and water molecules. Balance the charges on either side of each half reaction by adding required number of electrons. Same like oxidation number method only. But here, we have to do it clearly, because they will not give compounds here, they will give only ions. That is called ion electron method. Balance the charges on either side of the half reaction by adding equal number of electrons. If the number of electrons in oxidation and reduction reactions are not same, then multiply by suitable numbers to make the number of electrons same as it is, since we have done the previous also. Add the two half reactions so that the electrons in both equations should cancel out each other. The obtained equation will be a balanced ionic equation. Same like previous method, that is oxidation number method only, but here we'll consider only ions. So we'll do one problem easily, you can understand. Now let us see, as I told you here, only ions are given, only ions, acidic medium. So I'll write it here clearly now itself. I'll show you. Balance the following redox reaction by ion electron method. Fe plus 3, they have given already plus 3, and here it is plus 2. In the previous one, we have used to calculate, but here no need to calculate for sum. Now here sulfur, if you see, x minus 6. X minus 6 is equal to minus 2. So implies x is equal to plus 4. So it is plus 4. And here x minus 6, x minus 8 is equal to minus 2. Implies x is equal to plus 6. So this is plus 6. So we have to do like this now. Balance. First we'll do the redox reaction in two halves. So let us see. This is plus 3 changes to plus 2 decrease, and this is plus 4 changes to plus 6 increase. So oxidation half reaction is SO3 minus SO3 2 minus changes to SO4 2 minus. Similarly, reduction half reaction, we are writing two reactions. Reduction half reaction, Fe plus 3 changes to Fe plus 2. I'm doing it clearly, please note it down. So now, first step you have to write like this. Second step, what you have to do, same like, so here, oxygen state of sulfur is how much? It is plus 4, and it is here it is plus 6. So increase in oxidation number, that's why it is called oxidation half reaction, and this is called decrease in oxidation number, so it is called reduction half reaction. So here we can write Fe plus 3 plus 1 electron, because gaining of electrons is reduction, Fe plus 2. Similarly here, SO3 2 minus plus how many electrons? So here no need to write electrons. First we need to balance oxygen atom. So here I'm writing it again. So here 3 oxygens and here 4 oxygens. So to the side deficit of oxygen, add equal number of water molecules. So SO3 2 minus plus 1 water molecule, because here 3 oxygens gives rise to SO4 2 minus plus 2H plus ions, because acidic medium. And here nothing to do like that. So SO3 2 minus plus H2O gives us SO4 2 minus plus 2H plus. Now we'll do electrons. Now SO3 2 minus. How many electrons plus H2 as it is? How many electrons we have to do? Here, how many electrons? Here we have plus 4 to plus 6, it is 2 electron change. And here it is 1 electron change. So SO4 2 minus plus 2H plus. So multiplying this equation with the 2, because this equation with 1, this equation with 2. This equation with 1. Simple. So I'm writing directly final equation. Please note it down. SO3 2 minus plus H2O plus 2 electrons plus Fe plus 3. I'm writing the reactant of reduction half reaction. Both I'm joining. Plus here you should write this side, sorry. We have to write, because reduction is what we have to write. Here it should write here losing of electrons. So other side we have to write plus 1 electron. So plus Fe plus 3. So nothing is there here. Gives rise to. And here SO4 2 minus, I'm writing only products now. SO4 2 minus plus 2H plus as it is plus 2Fe plus 3. So here we have to write 2Fe plus 3, and here we have to write 2Fe plus 2 plus 2 electrons, because 2 into 1 electron, 2 electrons. So these 2 electrons gets cancelled. This is the final equation. So everything is balanced now. This is the final equation. Let us see the answer now. Fe plus 3, Fe plus 3. So it is plus SO3 2 minus plus H2O, 2Fe plus 2. Actually, this should be 2Fe plus 3. They have given wrong. Here you have tried 2Fe plus 3. 2Fe plus 3 plus SO3 2 minus plus H2O. 2Fe plus 3 plus SO3 2 minus plus H2O gives us to 2Fe plus 2 plus SO4 2 minus plus 2H plus. Now it is clear. I hope it is clear. Very, very important. Simple. To the side deficit of oxygen atoms, add equal number of water molecules. And the other side, add H plus ions if it is acidic medium. Or if it is basic medium, add equal number of OH minus ions. That is the only thing we have to do. So in this case, we have to separate the two equations, that oxidation half reaction and reduction half reaction. Divide the two reactions into two halves. That is, divide the equation into two halves. That is oxidation half reaction and reduction half reaction. After doing the same steps, that is number of electrons gained, number of electrons lost in both the cases, and water molecules added and H plus ions added in both the cases, then you have to equate reactant side and product side. Then afterwards you have to see electrons will get cancelled and you'll get the final skeletal equation, that is balanced chemical equation. I hope it is clear. What is the difference between the previous oxidation number and this is, in that we can give products as compounds, but here completely both the reactants and the products will be in ionic form only in ionic form, because here ferrous ions, ferric ion, sulfate ions, this sulfate ions, these sulfite ions. So ions only they'll give for reactants as well as products. So you need to do balancing. I hope it is clear. Please follow these steps. Easily you can get it. Next question. So Fe plus 3, here we have tried 2 Fe plus 3. This is wrong, because 2 Fe plus 3, then only you can have 2 Fe plus 2. Both are same. Now one sulfur, one sulfur. 3 oxygens plus 1, 4 oxygens, 4 oxygens. 2 hydrogens, 2 hydrogens. Everything is balanced now. I hope it is clear. Next question. So acidic medium, do it the same process. Balance the following redox reaction by ion electron method. So first we have to, I'll just show you here clearly. Plus 7 manganese changes to plus 2. So difference is 5. 5 electrons. And here Fe plus 2 changes to Fe plus 3. Difference is 1 electron. So 5 and 1 means definitely this should becomes 5 Fe plus 2. Gives rise to 5 Fe plus 3. And manganese becomes same. MnO4 minus gives rise to Mn plus 2. Because it is 1 electron change. This is 5, so this is 1. So we have to keep it like this. So this becomes 5 and this becomes 5. So easily you'll get now MnO4. So you have to multiply with 4 oxygen water molecules. So here you'll get 8 H plus, and here nothing you'll get. Simple it is, directly you'll get the question. So final equation also you can write it easily. So we have to write 8 H2O on the right hand side and 8 H plus on the left hand side. Sorry, 4 water molecules on the right hand side and 8 H plus on the left hand side, and 100% you'll get the answer. Let us see the answer now. As I told you, 8 H plus on the left hand side and 4 H2 on the right hand side, because 4 water molecules you have to add, and on the other side we have to add equal number of H plus. 5 iron, nothing is there, so no oxygen, so balance directly. So MnO4 minus plus 5 Fe plus 2 plus 8 H plus gives us to Mn plus 2 plus 5 Fe plus 3 plus 4 H2O. So follow the same steps which I have given in the first numerical. Please do it like that. Easily you can understand it. I hope it is clear. Next. Next question. So basic medium, again the same thing, but we have to do here, balance the following redox reaction by ion electron method using basic medium. So here just follow the same steps. Mn plus 2 is given, and here plus 2, and here it is changes to plus 4, increase in oxidation number by 2 electrons, and here Br02, Br minus, that is decrease in oxidation number by 1 electron, so total 2 electrons. So both are same, so no need to do balancing, directly you can get the answer. And only the oxygen atoms here, 2 oxygen atoms are here, no oxygen atoms, so we have to multiply with the 2 water molecule left hand side, right hand side we will get 1 OH minus. So simple it is, easily you'll get it. So basic medium we have to add OH minus on the other side, instead of H plus we have to add OH minus on the other side. And acidic medium we have to add H plus, as we already know. Now let us see the answer. As I told you, Br2 will be the same, 4OH minus on the left hand side, because 2 water molecules will be added on the right hand side. So 2 water molecules, 4OH minus on the left hand side. So Mn plus 2, Br2, MnO2 plus 2 Br minus, because 2, why? Because here Br2 and here we have to multiply with 2. So 2H2O. Easy it is. Just we have to multiply with water molecules. Since the left hand side 2 water molecules are deficient, we have to write it, and right hand side 2 water molecules, and left hand side we have to write 4H minus. Simple. Just we have to write water molecules, this and that. because by adding the half reactions, easily you'll get the answer. I hope it is clear. Next question. Balance the following redox reaction by ion electron method in basic medium. Same like this. So basic medium also you can see here. First writing the oxygen states of all the elements. Cl is 0 and here it is +1 and here it is -1. This is disproportionation reaction. What is this called? Disproportionation reaction. Do the same thing and here oxygen is -2 and here it is -2 again. Same thing. Anyway, oxygen is not changing. H minus is changing because it is changing to -1 to plus. Here oxygen is not changing. Hydrogen is changing from -1 to +1. So difference is 2 electrons. So easily you can try out easily. You'll get the answer. Let us see the answer now. So ClO2, Cl2 plus 2OH minus gives us ClO minus plus Cl minus plus H2. So this is the equation. Because this one electron change, we have to add one water molecule on the right hand side and one OH minus on the left hand side. Already one OH is there, so one more OH becomes 2OH minus. I hope it is clear. Yes. Next question. Clearing the drawings. Next, applications of redox reactions. The end point of a redox titration is determined by using a redox indicator. In titrations involving potassium permanganate KMnO4, that is called volumetric analysis. This you will do in the end of 11th class, at the end of 11th class. So in titrations involving potassium permanganate, the reagent itself acts as an indicator. The reagent itself act as an indicator. The endpoint is appearance. The endpoint is appearance of pale pink color. So the in titration of potassium dichromate against ferrous sulfate, diphenylamine is used as an indicator. So the endpoint is green color changing to deep blue. This you will observe in, these are nothing but redox reactions. This you will observe in volumetric titrations. What is this called? Volumetric titrations, which you will do at the end of class 11. Volumetric titrations and redox reactions application is nothing but we can do volumetric titrations by using redox reactions. What is a titration? We'll be doing in next chapter. So volumetric titrations. Anyway, these experiments you will do in the lab by the end of the at the end of 11th class. By the time you can understand. So in titrations involving potassium permanganate, the reagent is potassium permanganate, itself acts as indicator. The endpoint is appearance of pale pink color. Pink color of potassium permanganate changes to pale pink color or colorless. In the titration of potassium dichromate against ferrous sulfate, diphenylamine is used as an indicator. The endpoint is green color changing to deep blue. I hope it is clear. So this is the application of redox reactions. Not only this, so many applications are there. In iodometric titrations, the liberated iodine is titrated against sodium thiosulfate using starch as indicator. The endpoint is blue to colorless. Now, redox reactions as an electrode. A metal dipped in the solution of its own ions is known as electrode or half cell or redox couple. Example, zinc metal is dipped in zinc sulfate solution. Copper is dipped in copper sulfate solution. These are represented as zinc ions changes to zinc, copper ions changes to copper because zinc can displace copper ions from its solution and itself oxidizes to become zinc. So here zinc is displacing copper ions to copper, whereas zinc is changed to zinc ions. So I hope it is clear. So this is also nothing but a redox reaction. It is used in electrochemistry. This we are going to learn in 12th class. Daniel cell is also nothing but this discussion is of no use. So when zinc electrode and copper electrode are connected externally by a wire and internally by a salt bridge, a chemical cell is known as Daniel cell is formed. So just like pencil cell, which you are using in remote control. So remotes, TV remotes, etc. Zinc gets oxidized and the electrons lost by zinc will flow through the external circuit and reach the copper electrode and copper gets reduced. This Daniel cell we are going to do in electrochemistry. So it is no way discussion. Just redox reaction is useful in the construction of Daniel cell also. So with this we are done in this session we are done already. We have done how to balance the redox reaction by oxidation number method as well as ion electron method. So I am stop sharing this now. So the next session we'll do more about redox reactions. This chapter is very small chapter, easily